problem 30, you said. Okay, an ice cube in a freezer is growing, okay, due to accretion. Fine. Each edge increasing by, so if we remember 30, again on 365, if you remember, we looked at that cube. So we had this example in class. That's why I picked it, and then I picked one for homework. So we have that if this is x, then we have that dx over dt equals 0.2 centimeters per minute. Find the rate at which the surface area. So the surface area is 1, 2, so 2, 2, 2, so 6. So this is 6x squared. That's the formula for the surface area. Is changing at the moment when the length of one side. So we are asked to find ds over dt when the length of x is 8. That's all we have to do. We differentiate. They're both functions of time. So we have ds over dt equals 12x times dx over dt. That's all we need to do. And we're done. So then we plug in x equals 8. So this is 8, and this is given to us 0.2. So 12 times 8 times 0.2, and that's it. And the measurement unit has to be centimeters squared per minute. Why centimeters squared? Because I'm talking about surface area. Why minutes? Because I'm talking about time. And that's all we needed to do. Which part was difficult of this?
I just couldn't find, I think, like the formula for surface area. All I could find was like for radius. That was like messing me up.
But this is a cube. There is no radius in a cube.
Yeah, I know. I was like thinking that because I think the whole thing with like it being finding surface area in general was confusing, but I got it now.
Right. So this is, imagine that this is, of course, this is not a cube, but assuming that it's something like this, so now it's a cube. 1, 2, 3, 4, 5, and 1 here, 6. So the area of each side is x times x. So there are 6 identical areas. Good, very good question. Now let me go back here, and I think the book may disappear, but that's okay. We want to look at the next problem is still in 3.9, and it's problem 6. So let's look at problem 6 in 3.9.
I have a quick question
Yes,
about that one.
yes.
Problem 6.
Yes,
Problem
yes.
5. What is that number at the very bottom where it says 12.8.02?
12 multiplied by 8 multiplied by 0.2. 12 multiplied by 8 multiplied by 0.2.
Okay, thank you.
No worries. Thank you. Good. So let me go back. Alex, you're saying about problem 6 that is not there?
Oh, yeah, there's no problem 6. There's only question 5.
Okay, so was it on, should I make
Yeah,
one?
I was talking about 5, sorry.
No worries, no worries, but I remember Alex said the same thing. I remember. Okay, perfect. So in this problem, can I move this a little bit? Yes, I can. Perfect. Suppose that the price P in dollars and the number of sales X. So X, number of units, and P is in dollars. Fine. They are related by 4P plus 5X plus 2PX equals 92. So let me just dig up for a second. That's why I had, okay, let me continue. Functions of time. So P and X are functions of time. And the time is measured in days. Fine. Find the rate at which X is changing. So we want dx over dt when X equals 4, P equals 6, and dP over dt equals 1.6. So This is what we had last time, right here. Something like this, which was more difficult, right? So this is very similar, in which we were given dp over dt, blah, 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 and these numbers, okay? So it's the same. If you want to practice with problem 18, please do. It's the video is posted and everything. Okay, perfect. So all we have to do is we apply the same procedure or operation or operator to both sides, keeping in mind that everything is a function of time. So when I differentiate this, I have 4 dp over dt. When I differentiate this, I have 5 dx over dt. When I differentiate this, I have to be very careful because p and x are both functions of time. So 2 dp over dt times x plus 2p dx over dt equals 0. So all I have to do now is solve for dx over dt. This and this will stay. I will factor out 5 plus 2p. I will factor out dx over dt. And these two will go to the other side. They are both positive, so they will become -4 minus 2x dp over dt. Because they both have dp over dt in common, but I cannot combine them. 4 with 2x I cannot combine. They are positive here. They're moving to the other side. I have to change the sign. So finally, dx over dt equals all this over this. Sorry. So now all we have to do is just plug in those given numbers, and that's it. Oh, what is this? That's not good. Okay, so dx over dt will be -4 minus, so x is given to us as 4 minus 8, dp over dt 1.6, everything divided by 5 plus 2 times p, which is 12. So this is -12 times 1.6 divided by 17. I don't know how they want the answer. Let's read how they want the answer. Round to the nearest hundredth is needed. Okay, fine. So then I'm going to go here. I'm going to clear. And no, I don't want that. What do I want? I want -12. I want times 1.6. And I divide by 17. So they basically want 2 decimal digits, -1.13. -1.13. Now we need the measurement unit. X was in number of units. T was in days. Very good questions. So basically, I don't need to talk about related rates anymore. I don't need to talk about implicit differentiation. Related rates, implicit differentiation, what we did here. Okay, so you choose the next topic. You want to talk about differentiation of expressions or functions with exponentials and log. You want to continue with that. We can choose. You want to continue with linearization? That's okay. Differentiate. Yep, I have sometimes difficulty in pronouncing other things, so I know how you feel. Good. So let's go to the end of chapter 2. So I'll tell you the page. I'm flipping. Okay. Or I can just make problems up. Okay. So let's say I have natural log x multiplied by 4x to the third. And let's say x squared plus 1. Okay, so this is a function I want to differentiate it. How do I start? Anyone wants to try?
Maybe turn ln into e
No,
instead. No.
no.
How do you
No,
do the
this
product
is
rule?
this is exactly, yeah. This is one function, and this is the other. I will be using the product rule, of course. Very good. You can leave the 4 outside or not. So let's differentiate this. What do we get?
12x squared.
Yeah. So 12x squared times the second function plus, I have to copy this, times, can anyone differentiate this for us?
Is it 1 over x squared plus 1?
Please always remember, times the inner function prime. Please repeat that anytime you need to. Times the inner function prime. This has to be embedded in your system. So times what?
2x.
Times 2x. Since we're not doing anything with it, you can leave it alone. So here's another one. Let's say natural log of x cubed to the 4th power. How do I differentiate this?
Would you do the chain rule too?
Yes. So let's use the chain rule. 4 times this, cover it if you have any difficulties. A function to the 4th power is this times the function to the 3rd power times the inner function prime. How do I differentiate this? 1 over x to the 3rd times the inner function prime. What do I write?
X squared.
Yes. So you will simplify a little bit. So you will have 12 natural log of x cubed to the 3rd power over x. Leave it alone.
Too many inner functions.
Yes. 1, 2, 3. We always start from the outer further to the inner. Very good. Okay, one more, and we move on to the next topic so we can touch up on everything. So what if we have x to the 4th, e to 2x plus 4x cubed. How do I differentiate this?
A product rule.
Yes.
And you differentiate the
Yes.
4x.
Yes.
By itself.
4x cubed, e to 2x plus x to the 4th times times
Times 2x
e to 2x times the inner function prime.
times dy
Times 2.
Times 2. So let me refresh our memory. E to a function prime is e to that function times the function prime. E to a function prime is e to that function times the function prime. Plus, of course, just 12x squared. And that's it. You don't have to do anything else. Which one would like to continue with?
Linearization.
Linearization. Okay, very good. So let's look. Let's choose a function. Give me any function you want. And a point, or just x value. Make up a function, any function.
X squared plus 16.
Well, let's spice it up a little bit. X to the third minus 2x. And give me a value. Normally we call it a. Give me an a.
2.
2. Good. So we want to find the linearization called uppercase L of x for this function when a is 2. Okay, so this is what we're going to write. F of a plus f prime of a times x minus a. That's the formula for linearization. What do I do now? I will replace this in here. I will find f of a, which is f of 2. I will find f prime of 2, and I'm done. That's it. So f of 2, I'm going to plug it in a moment. Let's find f prime of a. Can anyone give us f prime of a? Sorry, I should have said f prime of x first. 2x plus 48x squared minus 2. Do we agree with this?
Yes.
Perfect, right? So 2x, 3 times 16, 48, x squared minus 2x prime, negative 2. I'm going to put this function in the graphing calculator and this function in the graphing calculator so I can determine their value at 2 in one step. That's how